Starting the company was the easiest decision we made. Keeping it going was obviously the harder part. Metallurgical grade silicon offers the benefit of being half the cost per kilogram of graphite, but being 10 times the capacity. So you have a very high performance but low cost battery, where 90% of the world's battery grade graphite comes from China. And so that provides a ton of issues. China produced polysilicon, which was a good enough product, but way cheaper and way more mass producible than the US could ever get to.
Welcome back to Clean Techies, the #1 podcast for climate tech entrepreneurs. I'm Somil.
And I'm Silas. Each week, we publish the secrets to success from investors, founders, operators, and experts in climate tech around the world. Building a startup is hard. Building a climate tech startup is even harder. But we make it a little bit easier.
We put a lot of effort into these shows, so we hope you enjoy. Don't forget to subscribe, leave us a review, and let us know who you think we should have on next.
With that, let's get into today's episode. Hey everyone, quick note for you. You're currently listening to the free preview of this episode. If you'd like the full thing, the full shebang, go over to our Substack. That's cleantechies.substack.com/subscribe and become a paid subscriber. Any paid subscription gets you full access to the show on the Clean Techies Substack. Hey everybody, we get the amazing pleasure to talk today to Jonathan Tan from Coreshell, CEO and co-founder of Coreshell Technologies, a battery technology company creating a replacement for the graphite that goes into batteries using basically, they call it metallurgical grade silicon, which is a fancy way of saying silicon that is not as processed or not as high quality. So it's much cheaper, right? The whole idea is to bring down the cost of batteries, especially when it relates to EVs. So you can get pretty good performance while reducing the costs pretty substantially. In today's conversation, Jonathan walks us through a little bit of an intro on himself, and then we also dive into their technology, of course. And then after that, we have a pretty long segment about the electrification race between the US and China. We talk about a lot of different things. There's some good content. I think you'll like that. We also touch briefly on what a Trump administration might mean for the battery tech sector in the US. And I guess you could say, maybe surprisingly, it's not as negative as we might think, but I think you're going to like that section as well. After that, we then dive into what are the actual innovations that have happened in the battery chemistry space. And frankly, it's not that much. So stay tuned for that part. Finally, we wrap up with a segment on why the EU, or at least the EU battery tech ecosystem players, are jealous of the US. I won't spoil it. Get to that part and you'll enjoy it. That part will be behind the paywall. So if you're not a paid subscriber, become one today. If you are a paid subscriber, thank you so much for being here. Oh, and one last thing. Shout out to our sponsors, Goodwin, for making this episode possible. More about them later. All right, without any further delay, let's get into the episode. All right, welcome to the show, Jonathan. How's it going?
Good to see you, Silas.
Yeah, I'm super excited for today. We've talked about this before the show, but let's get straight into it. Tell us a little bit about who you are and just kind of what I guess we could say, who is one clean techie that you'd really like to have dinner with? You can broaden that if you like, but who's somebody that's really fascinates you?
Yeah. No, I think you gave me this ahead of time, and I was trying to think of a clean techie. So I'm Jonathan. I'm CEO, co-founder of Coreshell Technology. We're going to go into it. We're a battery technology company that's really trying to make the most amount of impact in the adoption of clean energy technologies and battery-powered applications as much as possible. Yeah, I was trying to think about this question of clean techies that I'd want to have dinner with, and it really kind of made me think of more broadly about who inspired me to really start Coreshell. And someone that I follow that I've always been a big fan of is a philosopher and professor called Peter Singer. He's a applied ethics philosopher from Australia. And his perspective has really been about how do we make the most measured and analytical takes on which actions we take that will have the most amount of impact in the most profound way to reduce human suffering on a global scale. And that was really the main reason we started Coreshell, is how do we address climate change in the most impactful and precise way that would lead us to proliferate clean energy adoption and help reduce climate change as a source of a lot of global suffering.
I mean, that's a very thoughtful answer, man. I think a lot of people could take note to start their process of building a company that way. So I appreciate that. I'm gonna have to look into this guy. I have not heard of him before. So just tell us a little bit more about your journey into entrepreneurship and into climate specifically.
Yeah. I got interested in climate tech, I would say pretty early on, but really heavily focused once I started getting into college. So I went to UC Berkeley, trained as a chemical engineer there. And I think that was the beginning of my journey in thinking about how do I apply the skills that I was working towards something that I thought was really meaningful. Traditional chemical engineering is really around, processing a lot of, large petrochemical, oil and gas refinery. And I really wasn't too excited about that. So started off my career really working in wastewater and waste gas recycling. So cleaning up those kind of heavy industries that had a lot of pollution and had a lot of carbon footprint. But then started Coreshell really pivoting to work on something on the other side where we felt like we could make a proactive improvement in a major technology that could really spur the transition as quickly as possible. And that's really when we started Coreshell to focus on batteries.
One real quick question I have on the wastewater stuff was that driven by were the corporates buying that technology to mitigate like the output because of like moral concerns or just because they were getting fined by the EPA? Like what was the actual motive behind them working on that technology?
Yeah, honestly, at that point, this was part of the learnings that we had starting Coreshell. Part of it was government regulations in terms of reducing pollution, but I would say that the bigger driver was economics. I'll be honest,
Mm.
right? The economics of recycling usable water or usable product back into something that could generate value for them as, an entity was the major driver. And so I think that also sort of influenced the way that we thought about Coreshell and being practical, right? Going back to like the Peter Singer, reference that we talked about earlier on, we think about things from a utilitarian perspective, right? I mean, I think we are very ambitious and we want to be stewards of making this transition. We have to be practical minded in terms of what can actually make an impact, what would actually cause people to transition away from the traditional energy sources or fossil fuel technologies they have. And economics, I think, is just a major part of that, economics and scale. So that was part of the thesis that we started Coreshell with, for sure.
Yeah, that's quite interesting. I like to hear that space because it's not something I think a lot of people know about. I mean, it's definitely an industry now, and I don't know how new it is. I haven't really spent a lot of time diving into it, but that's helpful context. I guess with that, then let's continue on. Like, how did you tell us a story of like the origin of Coreshell and really give us some of the details of actually starting it?
Yeah, so 2017, I think my co-founder and I were both tired of our previous jobs. And so people always ask us, was it hard to start a company after working in the industry? And honestly, I would say that starting the company was the easiest decision we made. Keeping it going was obviously the harder part. But we wanted to start back in 2017 because at that point we had the realization that we had developed a lot of skills working in industry. Both Roger, my co-founder, and I happened to be good friends in college, but worked serendipitously both in thin film materials. So myself again on the polymer membranes for wastewater and waste gas separations, and then Roger worked in the thin film solar industry, clean tech 1.0. So we both took a lot of the learnings from that and wanted to apply it to again batteries because we at that point recognized batteries and energy storage were going to be really one of the most impactful, if not the most impactful technology in this new energy. Electric vehicles to energy storage on the grid, all that stuff relied on getting a cheaper and better battery out the door. So our initial concept was really solving battery degradation using thin film coatings, right? So the industries that we had already scaled and developed our careers around, how do we apply those to solving something fundamental in batteries? It went through many different cycles since then, and we've had multiple different breakthroughs. And now the newest form of the company and the technology is applying that nanomaterial and thin film coating technology expertise to solving metallurgical grade silicon as a replacement for graphite. And we can talk about the value proposition of that one much more, but at a high level, metallurgical grade silicon offers the benefit of being half the cost per kilogram of graphite, but being 10 times the capacity. So you have a very high performance but low cost battery that's also 100% locally sourceable in the US and Europe, and so offers a lot of benefits from the supply chain perspective as well.
So that's interesting. So your original idea was about film coating, and it's still essentially the same technology that you're working on, just maybe in a different application of what you had originally thought.
Yeah, I think it's what I would say is it's a more focused application. So originally we had developed thin film coatings to solve battery degradation across different lithium ion chemistries. So various different types of lithium ion coating both the cathode and the anode, really solving degradation of lithium ion from various different perspectives. We made a pivot once we recognized that one of the thin film coatings and nanomaterial packages that we had developed really had this profound impact in making metallurgical grade silicon commercializable. And up until now, silicon anode technologies have been around. There have been a lot of people studying it, but no one had really worked on solving metallurgical grade silicon, which was the lowest cost form of the silicon that could be put into a battery. So that was the real breakthrough. And now, because of that breakthrough, we've transitioned the company into really focusing that as our primary product, while still keeping, the portfolio of other thin film coating chemistries for cathodes and other chemistries still within the R&D, but just not the main focus on the product for initial commercialization.
You know that feeling when you meet someone who shares your vision for the future? It just clicks, like two peas in a pod. Well, that's exactly how we felt when we met Goodwin, who we are proud to have as our sponsor.
Being the first major law firm to set up a climate-specific startup and venture practice makes them exactly the kind of partner we are excited to work with. They realize that there are a plethora of challenges to building climate tech startups, and that's why they have built an entire suite of resources for founders, investors, and entrepreneurs in the space. They even offer several tailored pricing methods. And guess what? It doesn't matter where you are listening to this. Goodwin is a global law firm that you can trust to be your partner through it all, from incorporation to exit. They've got you covered.
Go to goodwinlaw.com and tell them Clean Techie sent you to get exclusive access to startup resources. All right, back to the show.
Okay, got it. And then I guess, broadly speaking, what would you say is the impact that you hope to have with Coreshell?
Yeah, so I think the main thing that we've noticed, and especially in the past 9 months, is that the electric vehicle industry, which is one of the biggest industries, I would say, in the clean tech space, has hit a bit of a roadblock as of late. And from our perspective, some of the biggest challenges are again around the cost and the scale of these electric vehicles. The battery is a major portion of the bill of materials. It's the largest one. It's anywhere between 30 to 50% of the cost of the entire vehicle itself. And it's something where electric vehicle manufacturers are spending a lot on their batteries. And so therefore they have to, price the vehicle at a very high price point. And so most electric vehicles right now reside in sort of that luxury end of the market. And what we want to do is to really move it from the luxury end into being a mass market product that's accessible by everyone, that's produced widely, that everyone can participate in this clean energy revolution, rather than having it sort of reside in the upper luxury class type of product.
Got it. Okay, so with that, I guess break down a little bit for us the technology in a slightly more detail, and specifically why it's important, because you talked about some of the issues around scale, so just kind of dive into that, why it's important, and then some of the supply chain concerns.
Yeah. So currently, right now, lithium-ion batteries, for those who haven't really studied it in detail, are reliant on graphite as being the primary anode technology. So, the battery itself has a cathode and the anode, positive and negative. So half of the battery relies on this graphite supply chain. Majority of the graphite, actually a large majority of the graphite, over 90% of the world's battery grade graphite, comes from China. And so that provides a ton of issues. One is that graphite has limitations in both its cost and its capacity, right? So that is one of the limiting factors in creating a higher range and lower cost product. The second is the supply chain risk side of things, which you already alluded to, which is that if you rely on one single country or one single region to produce a majority of the raw materials or the supply for your battery, you're really putting a lot of risk on that sort of sole source, right? And that becomes something that I think, the US and Western Europe and a lot of countries have started to recognize that that's something, that will have a risk associated with the industry at large. So we want to try to solve all those challenges. And that's why, when we had that breakthrough on enabling metallurgical grade silicon, we really felt like it had all those attributes in abundance in terms of solving those challenges, right? So as I mentioned before, metallurgical grade silicon, silicon in general offers that high energy density, so that you can create a vehicle that runs longer, that has longer range. Other types of silicon can be very expensive, but metallurgical grade silicon, again, has half the cost of graphite. And so you get the benefits of that long range without having to pay a premium. So the long range vehicles are no longer, just the Lucid Air. Not that it's not a fantastic product, but, we want that long range to be accessible for, folks that are, buying the F-150 or buying a Chevy Bolt or, even going lower cost in the price. And then the supply chain decoupling, so silicon is produced widely in many countries. It's actually the second most prevalent element in the Earth's crust. It's widely available in all different regions of the world. And that's where we're really excited. We just announced in the past few months that we have a partnership with Fairglobe, who operates mining of silicon in West Virginia, in Alabama, as well as in Europe. And so that allows for a domesticated supply chain where you're not relying, again, on that sole source for your raw materials that would come from China or from other regions. You can really kind of distribute, and distributed, sort of like distributed energy, distributed supply chain offers much more resilience and capabilities.
Climate tech founders are taking on a huge challenge. Not only do they need to know how to build a startup, but they also need to deal with hardware, have a strong handle on climate policy, know how to fundraise from diverse investor types. It's a lot.
That's why we made Clean Techies, the #1 podcast for climate tech entrepreneurs. In addition to our jobs, we devote 20 hours a week to producing this podcast for you. This way you can learn from the people who have walked the path before you, learn from their mistakes, and gain insights on navigating this complex journey. If this mission resonates with you, we are asking for your help. It takes a lot of effort and it's not free.
If you are already a subscriber and want to help, start supporting us today by going to Substack and clicking Upgrade to Paid. Thanks for helping all the climate tech entrepreneurs like you. And so are you guys aiming to become a producer of batteries or just the materials that will then be sold to other manufacturers?
Yeah, that's a great question. Right now we have really just tried to demonstrate the technology in the full format of a battery. And the reason why we're doing that is because we're replacing not just a portion of the graphite, but almost all the graphite with silicon. So it is a wholesale chemistry change from that perspective. And the one thing about batteries is that, when you're making such a large chemistry change, you can't just think about that one component. You really have to design the whole battery to take in all the different systematic changes that come from replacing the anode. So right now we're sampling at a full battery level. We're demonstrating at a full battery level. We have actually some partners that are interested in purchasing the batteries that are made from the technology. But in terms of the long term and the broader global market, we're not saying right now that we're going to be a gigafactory battery producer by ourselves. We still focus on the technology, which is something that enables this anode to get to market. So we think about ourselves as still a battery technology and materials innovation rather than supplying the full scale cells at a large scale production.
Yeah, I think it's a pretty common play, and it seems like a pretty wise play to not necessarily you don't have to nail down one of the particular business business models initially when you have potential options in the future. So I appreciate that. But broadly speaking, just to kind of wrap that up, your technology is effectively a new method of producing silicon that can replace the graphite. So you're not making graphite, you're finding this I'm not a metallurgist, so I don't know a lot of these things, but you're finding this very abundant material, processing it, and turning it into a replacement for graphite, which will allow either you or other battery manufacturers to produce batteries that have longer range and have a much cheaper price, which should overall reduce the cost of EVs or other things that have batteries inside of them.
Yeah, that's exactly right. Yeah, so that's the key enabling technology, and that's a great summary of why we think we have a value proposition and what the technology really does. And in addition to that, like we mentioned, the decoupling of supply chain risks, all that is really nicely packaged into one anode side technology.
Great. Let's shift a little bit to trends in general. We've got a couple of bigger topics we'll crack open here. The first one I want to talk about is the electrification race against China. I mean, there's been a lot of discussion around this whole idea. I mean, some people, not me, but some people have called it the second Cold War. I don't know if you like that term or not, but some people have called it that. I guess what fundamental problem are we facing from your perspective in this kind of electrification race?
Yeah, so I wouldn't really refer to it as a Cold War, although, I think depending on your perspective, I think you could call it that. But to me, this is a global challenge that we're trying to solve, right? And China and the US also both being two of the largest in terms of carbon footprint, both on a total level as well as a per capita level. I think we both need to participate in that. So I wouldn't say that it's a Cold War from that perspective, or I wouldn't think that the Cold War analogy is beneficial for us to really think
Mm.
about moving forward. However, that doesn't mean that I think that monopolization or the near monopolization of the supply chain originating from one place, both in terms of the raw materials as well as the products created from those raw materials, right? So China is also one of the biggest producers of batteries. They're leading actually in a lot of electric vehicle production as well, which I think is all a good thing. But if US and the Western Europe really relies on that, I think there does create a lot of challenges in terms of the risk and the acceleration of adoption of those technologies in these other regions. So for example, if you have a sole source for all of your battery grade anode material, what happens then if the geopolitics get in the way of that, right? And clean energy technologies and proliferation shouldn't be dependent on geopolitics. But in that scenario, it would, right? So if there came a time where the two sides of the globe are not at odds with each other geopolitically, then does that mean that the US will then stop being able to produce
Yeah.
batteries and electric vehicles? That's really not a great situation for us to be in from a whole sort of global clean tech perspective. The other side that I see as a potential risk there is on the innovation side as well, right? So if China controls all the supply chain for this material, they will have a heads up in controlling what types of products get out there and the innovation that happens and all the things that you can do with that raw material and that product. Does that slow down, for example, the innovation in the United States, whereby we have to get material from China, they control the production of it, they control the quality, the specifications, all the things that product, that raw material starts off at. It limits the amount of innovation and innovation that can be impactful here in the United States and in Western Europe. So for all those reasons, I do think that having a delocalized supply chain or having a supply chain that's decoupled from a single source really provides real tangible benefits for
Mhm.
us to consider. So I do believe that in the spirit of trying to get as much adoption of clean energy technologies, finding a way to not be solely reliant, geopolitics aside, has tangible benefits as an industry, as a place for innovation, and as a best chance for getting the most amount of adoption as quickly as possible.
Yeah, so if I understand this correctly, your general principle would be if you're focusing in that question on like actually decarbonizing industry and making
That's right.
electrification happen, not just from an energy security perspective, but we're talking about just purely like if we genuinely care about decarbonizing the world, we shouldn't be reliant on one particular place where all this is coming from because what happens if the tides turn in a way where we can't partner with them anymore and there's no ability to do that. We're kind of we're up a creek without a paddle, right?
Yeah, it's exactly right. I think there's plenty of analogies that can be built there. The solar industry is one of them. We're now reliant on China for the majority of the solar panels that are made. Is that beneficial for us? I think it brings benefit in terms of they can produce very cheap solar panels, but what happens to the solar industry if all of a sudden, China doesn't want to produce solar panels for the US anymore, or the countries are not at ease with each other. So, that type of codependency, I think is just bad for clean tech in
Mm-hmm.
general. And so geopolitics, again, energy assurance and geopolitics aside, I still believe that the US does and should have a vested interest in making sure that there is a domestic supply chain of the
Mm-hmm.
materials and the
Yeah.
production for batteries and electric vehicles. And I
I
think
mean,
they will, regardless of what happens.
yeah, and I mean, we saw like a slight version of this happen with the solar panels back when there was a couple new rules around the information they had to understand, like were these sourced ethically, et cetera. I know some of the solar panel manufacturers in the U.S. they sold out production for a long time when that happened
That's
because
right.
there was nowhere else to go, right? I guess, do you have any particular, on this topic still, do you have any particular points or maybe advice or like things that you would say to focus on to whoever the next administration is, what they should focus on if they want to continue kind of competing in this electrification race, trying to onshore some of this production or at least decoupling in some way from a single source of on the supply chain?
Yeah, so I think there's a lot of lessons that we should be taking from how the previous industries and clean tech industries have shaped. And I think solar is a really big example of this, which is that, while the US was really focused on very interesting and really, I would say, moonshot type of technical innovations, the thin film solar industry being one of them, which, again, my co-founder, Roger, had a front row seat because he was part of that and was one of the one of the leading startups for developing thin film solar. So a lot of that materials innovation is stuff that the US is actually frankly very good at because of the national lab resources, because of a lot of the innovation ecosystem that we've built up here. But I think there's a little bit of risk that the US puts itself in kind of chasing after just the 10x breakthrough type of technologies solely, right? And I would say that the venture capital ecosystem is set up to go after those, right? Like the 10x type of rewards. The Department of Energy and the sort of research grants that are out there focus that. And kind of going back to your question around the administration, I think all of it kind of folds into promoting fantastic technical innovations, but not really thinking about the complete picture in terms of, again, economics and scale. And that's really what China has repeatedly been able to beat the US at. The lesson from the solar industry, the reason why thin film solar really went away was that China produced polysilicon, which was a good enough product, but way cheaper and way more mass producible than the US could ever get to. So going back to what Coreshell thought about when we first started the company is that we recognize that, hey, we can't just be innovating based on just innovation. We need to kind of put the boundary conditions of what is imminently scalable, what is very cost effective at an industrialized scale, and what is minimally disruptive to the manufacturing and the current supply chain that's already been built up. And that's really where, again, focusing on metallurgical grade silicon has, in our opinion, the most benefits because it actually has an even better supply chain and scale than graphite does here in the United States. We just take the local ecosystem. And it doesn't require you to build a different type of battery manufacturing facility like solid state does, right? Which is, again, a very fantastic technology, but requires you to think about how do you make this battery in a totally different way than the gigafactories that are being built today. So all those things have really fantastic technical innovations behind them, but I'm concerned about how soon will they actually make an impact in this industry, and how soon will consumers who are out there be able to realize some of the impacts of the innovations that the US has really focused itself on.
Yeah, so I guess to try to make sure I get that right, the summary would be to focus on the things that have like a really immediate impact, not just going for moonshots because you might only have a couple companies come out of that, but if you can invest into things where it's like we got to focus on overall reducing the cost so we can get to scale with these things, that's going to be helpful in long term. One thing I often think about is along with all of this, right, with the electrification race, if you will, there's a whole decarbonization of industry that's happening, right? And I think that my personal opinion on this is often if you can reduce the OpEx of a lot of these industrial production means, you can actually get to a place where you're maybe not going to beat China in terms of price, but you can get much more cost competitive because you're reducing the overall cost of producing these goods. And I think this goes hand in hand with onshoring or at least nearshoring industrial production for some of these battery minerals or whatnot.
Yeah, no, I think the thinking I'm aligned to, which is that let's find a way through technical innovation to optimize things that we can produce here in the United States that don't require sort of a whole new reinvention. You don't want to reinvent the wheel from scratch, let's say, put it that way, and try to kind of build out some of this industry from scratch with a whole new innovation that no one has ever kind of even built a small scale production facility around. Let's try to innovate on things where you can really drive and optimize the cost of the materials, the efficiency of the process. A lot of those efficiencies, those are the types of things that have actually made the most meaningful impact in the consumer products, or the consumer in the products that the consumer can purchase today. So I think you're exactly right, and those are the types of thinking I think that China has been good at. When it comes down to like government policy, I think China has done a much better job of thinking from that perspective and really funding the ability for a lot of these companies in that region to not really just think about, okay, let's go back to the fundamental material science research of everything. Let's think about what are some of the things that we can scale readily here in this country. And it's part of the reason why they have aligned themselves with lithium iron phosphate and with graphite, is that those are the things that they already had a footprint in being able to scale. And then taking them and trying to make that as efficient as possible in our region. So the US, thinking from that perspective, I think would benefit itself a lot more than just kind of thinking again about what is the moonshot breakthrough technology that has a 10x variable, but still has a really long roadmap in terms of its technology readiness level, and then on top of its manufacturing readiness level.
So similar to the same thread, I'm curious, and we've touched on a few of these things already, but do you let's say a Trump administration comes in the next term, right? If we see that, do you think, I mean, obviously it's pretty clear that Trump is not a clean tech person, and it doesn't seem like his administration is, but if his focus is on competing with China, which it appears to be, I mean, it's sometimes hard to tell what he's actually planning to do.
Yeah,
But
it's hard to read the tea leaves with that guy. So
yeah, but
my God.
if that is the objective, is to kind of compete with China, do you foresee that the battery industry at least would still be okay in a Trump administration, or do you foresee general like hits to policy or anything that's going to slow down the overall industry? What is your take on that? All right, everybody. Thank you so much for tuning in to the free version of the Clean Techies podcast. On this episode, we have reached the end of our journey together. Well, I guess we don't have to have reached the end. If you'd like to get the rest of the episode, the rest of our amazing discussion with Jonathan Tan, you can become a paid subscriber. And if you do, you can get the rest of the episode. What do we talk about? Well, you're in for a treat. I'll give you a little bit of hint just to make you interested. So you can hear us talk about Trump, batteries, and climate tech policy, kind of all those things mingled together, what it might look like. We talk about how economic development and clean tech are not opposed. Maybe not a surprise to some of you, but some people might find that interesting. And we talk about how there isn't really any major innovation in battery tech landscape since lithium ion, effectively. I mean, there's obviously some capacity items, but he talks about we don't really have a lot of breakthrough technologies for the past while, and his take on why that is. We also discuss, and this is probably the part that blew my mind the most, why the EU is basically jealous of the US and why that is. So that one was quite interesting. A few other things as well. If you'd like to get that and the rest of our discussion, always, not just this episode, but all episodes, you can become a paid subscriber by going to cleantechies.substack.com/subscribe and pick any paid membership. We've got monthly, we've got annual, we've even got founding member. There's some special perks there if you read into it. But if you pick one of those and become a subscriber today, you can get the full episode as well as all the other perks that come along with it. We're kind of refining what exactly that looks like, but guarantee you it's valuable. I mean, just putting this podcast out is pretty valuable, we think, at least. So if you like the work we're doing, you want to support what we're doing, become a paid subscriber today. And if you're listening to this prior to Climate Week, we are going to be there, both of us. So if you'd like to meet up and hang out with us, drop us a message. We are likely putting on at least one event, and we'll be attending many. So I'm sure you will be as well. So reach out and we will get in touch there. Thanks so much, everybody. Talk to you later.